When you're building an application, usually you need to get data from an external source like a server or an API, and this is where data fetching comes in. So let me paint a quick scenario for you. Think of data fetching like ordering a package online. When you order a package and you receive it, you need a place to store it. That's where the useState hook comes to play. Another thing you want to take note of is that the useEffect hook could be useful in data fetching because it's a side effect. And finally, when you order a package, you know it doesn't come immediately. You have to wait for some time for it to arrive. This is very similar to what happens when you're fetching data. Your data may not come immediately, and instead of leaving the screen blank, you want to include a loading state. Now that we understand the basics of data fetching, let's go into our code to fetch a list of posts from an API and render them in our React application. We'll start with a basic functional component that simply displays a placeholder message. The first step is to store the response data, and for that, we'll use the useState hook. We'll have two slices of state, the first to track posts and the second to track the loading state. The step is to make the API request to fetch the actual post data, and for this, we use the native fetch to make a GET request to the post endpoint of the JSON placeholder API. We'll call the setPost to update state with the API response, and we'll also set loading to false. We want this request to happen when our component mounts, so we'll put the fetch call inside a useEffect hook. Finally, we map over post states to display each post title and the body. Right now, we are fetching all of this data at once, but what if there were thousands of data coming from this API? Loading massive amounts of data on your web page can significantly slow down the performance. And this is where pagination comes in very handy. Pagination breaks down large amounts of data into chunks that allows users to easily navigate through them with pages. So let's go back to our code to improve it and implement pagination. We start by setting up the state for the current page using the useState hook. Next, we define the page size to determine how many items should be displayed per page. For this, we'll set the page size to 20. To calculate the total number of pages, we divide the total number of posts by the page size. Now we need to create the goToPrev and goToNext functions that will help us navigate between pages. These functions will be passed as onClick handlers to the previous and next buttons that we'll add to the UI shortly. Now here's the exciting part. We use the start and end values to slice the posts array based on the current page and the page size. So let's go ahead to update the UI and map over posts per page instead of all the posts. We also create the previous and next buttons and pass the functions we created earlier. Finally, for good user experience, you want to disable the buttons if there's no next or previous page to go to. And to do this, we create the canGoPrev and canGoNext variables. And then we pass these variables to the disable attributes on our button. So let's go ahead to test it out and see if everything works. And yeah, it works the way it should. And there you have it. We've just covered data fetching and pagination to make sure that your users have a seamless user experience and that your web application is very optimized. Here's the repo for the code in case you need to reference it. As always, thanks for watching and I hope you learned a thing or two. See you in my next video.